You will be doing some more of those questions for me for homework. Okay, you'll finish off those questions that are there. It's just carefully looking at those things that, that we've got. Aha. I hear you say, I wonder if we'd ever be able to find out, if we were told what the probability was, whether we might be able to go backwards. So obviously, seeing as just as I was going around the room just then, about 7 people said, oh my God, how would we go backwards? This sounds so interesting. I've quickly planned this bit so that I can show you how to do this bit. So,
no one said that.
7 people said it to me. The probability of them saying it is 0. Okay, fair enough. We're still doing it anyway, though. So, the inverse normal distribution. We now know how to use. How to use a calculator to value to use a calculator to value of the variable. That doesn't make any sense. Whatever. To find a probability, basically. We might want to. What we might want to do is reverse. Given a probability of being in a particular region, how do we find the value of the boundary? So just what we had before is we said, oh, cool, if I know what this value is down here, I can work out what this probability is. Okay? Now I'm going to say, you know what? This probability over here is 0.1348. What's this? We're going to go backwards. Okay? Because actually in real life, there are sometimes things where we find out what the probability is, and then we want to say, okay, well, I wonder what the boundary is for that kind of thing that we've got. We're going to draw a sketch always for these, okay? And I'm going to show you how to use your calculator. So first of all, we've got that this variable is normally distributed, mean of 20, standard deviation of 3, and we want to find to 2 decimal places the values of A such that the probability that the variable is less than A is 0.75. Now, it's really important that you draw a sketch for this, and I'm going to tell you why. So there's the sketch, not very well drawn, but it's going to be on this side, over here. That's where A is going to be, and I know that this area is going to be 0.75, okay? Everyone's calculators, who don't have the big boy calculators, will always tell you will always tell you when it's on the left-hand side. It will tell you the probability up to that particular value, okay? We call this a left-hand tail because it's trailing off to the left-hand side. So I've said here, the area requested by your calculator is the probability up to the value of interest. But the graphics calculator is more advanced. You can assign whether you want the probability to tail to the left, like in this case, or you can assign if you want the probability to trail to the right, or you can actually do them where you want it to be symmetrically in the center. But I'm always going to do my calculations as though that they are trailing to the left so that it's the same for everybody else that we have. So what you're going to do is you're going to go over to your calculators. We want the probability to be 0.75. You're going to go back to the stats menu, and you're going to go distribution, normal, let's get that out of the way, inverse normal, because we're going in reverse here, and calculator people with these ones, just leave it on left for now, because it's trailing to the left. You're going to say that the area that we're interested in is 0.75. I believe the standard deviation was 3, and the mean was 20, is that right? Yes. Is that what it says on the page? And you just put that in your calculator and you get told that the value of A, that value on the boundary, is 22.02. So that must mean this thing here is 22.02. In other words, A is 22.02. Now, if you wanted to, you could check that this works. So I'm going to just go back and prove to you that it works. I'm going to very quickly do it on the cumulative one. And I'm going to say, whoosh down that end, 22.02 there, and look, you get 0.75, basically. I haven't done it very accurately, so that's why it's not perfect. So it does work. Okay, we can do the next one. The next one says, I want to find the probability that x being greater than a is equal to 0.4. So I'm going to do a sketch. That means greater than a is going to be 0.4. So a is still going to be on this side, because you can think about where it should be with like 50%. So a is going to be somewhere over here, and this time, this bit is 0.4. But because we can only do things on our calculator for things up to that value, this thing that we have on this side is 1 minus 0.4, which is 0.6. So we're going to use 0.6 on the calculator rather than 0.4. Further maths, not further maths, I know it's people in further maths have this calculator. If you have this calculator, you can go back to the distribution and the inverse one. You could do the tail to the right and do 0.4, and you get this answer of 20.76. Everyone else, it is though your calculator is on the left and with 0.6, and you still get the same answer of 20.76. Make sure you can do that on your calculator while I just write that down. So we go, A is equal to 20.76, okay? So the diagram is really important here. Part C, it says, what is the probability that x is between 16 and A? Now this is a problem because the calculator only knows how to do things that look like this, okay? This is the only thing that a calculator knows how to do. It doesn't know how to do it when the diagram has got something else going on. So I'm going to have to draw a diagram. And I want it to be between 16, well the middle bit is 20, isn't it? I should have put that on. 16 is over here, and A is somewhere over here. And I want that to be 0.3. So this is the thing that I want to be 0.3. What do you think I need to do here to be able to find out what A is?
From 16 back.
Good. I need to work out what this area is and then add it to 0.3. So I'm going to quickly work out the probability that x is less than 16, and then I'll add it onto 0.3. So I'm going to go back to my calculator and I'm going to work out that it is less than 16. So that's good, that's still really extreme, less than 16, and you've got 0.0912. So now I know with my diagram that the area that they have up to the value A is 0.0912 and 0.3, which is 0.3912. So that means I can then go to my calculator, I can go to the inverse part, and I can say that the area is 0.3, I can't remember what it was, 912? 0.3912, and I get 19.17. So A is 19.17 in this case. Can you tell me something that I have not drawn very well on my diagram now that I found out that value? Hamza? Yeah, I predicted that A was larger than 20, but it's not. Actually, A is 19.17, so really, the diagram actually that it was talking about looks like this, and this is the area that's 0.3, because actually 19.17 is smaller than 20. But this isn't meant to be a perfect diagram. It's meant to be a visual tool that helps you predict how you might make some of these inverse things that you have. So we always need to have the probabilities on the left-hand side, unless you have the graphics calculator, in which case you can decide right or left, and it just saves you one step of doing a 1 minus kind of thing, okay? Can I go on to the next page? We've just got a couple of things to have a quick go at, and then we're done, okay? Here we go. The IQ of a population is distributed in the same way as before. It's the IQ test here. Mean of 100, standard deviation of 15. Determine the IQ corresponding to the top 30% of the population. So let's just have a think about what that might look like as a diagram to begin with. We have 100 in the middle. The top 30% is going to be this group over here, where there's 30% of a high IQ. Sometimes you might have to interpret. Is it like a big one, or are they actually talking about like the other end? And we're going to try and find out what this value A is here. So the probability that x is greater than A is 0.3, which we know, if we're trying to find out what this area over here is, this is 0.7. So we know that the probability that x is less than A is 1 minus 0.3, which is 0.7. And then we use our calculator to find out what A is. It kind of feels like, well, we haven't even done any work. But it's because you're all doing it on the calculator. So I'm going to go back and find out that it's 0.7. It's a left tail 0.7, standard deviation of 15, whoops, and average of 100. So you get 107.866, which is basically 108, because you'd probably give someone's IQ score as a whole number.
Round it up.
Then we're being asked about the interquartile range. What's the lower quartile?
The low 25%.
The lower 25%. So I'm going to first of all work out the lower quartile will be over here. Let's call this one, I'll call it L. The lower quartile is where this bit over here is 0.25. So the probability that X is less than the lower quartile is 0.25. So I can find out what L is equal to by using my calculator. So I'm just going to go back to the calculator. This time I'm going to change it so it's 0.25. And we get 89.88. The upper quartile, what do you know about the upper quartile? The upper 25%, so how much is below it?
75%.
Yep, so there's 75% of the data below it, so this is all 0.75. So the probability that X is bigger than the less than the upper quartile is 75. And so the upper quartile is 110.12. So the interquartile range is 110.12 minus 89.88, which is 20.24. And there's a little note down here that isn't one of those facts that you need to memorize, but in general, the quartiles of a normal distribution are approximately mu plus 2/3 of the standard deviation and mu minus 2/3. And you can see that from here. 2/3 of the standard deviation is 10, so you can see it's at 90 and 110. So it's just a pattern that you notice with the normal distribution of how that looks. Yeah, Hamza?
You said if the answer was just 20, would they give the marks?
No, this is not something to use, this is something to notice, not to use. Yep, that's what you were going to say. Yep, don't use that, but it's just like an interesting note. If you go into doing a statistics kind of thing in your degree, you might use that as like a shorthand if you're out on a field study in biology or something. That's the kind of thing that you might be able to use, that sort of stuff. Okay, I know we've only got 10 minutes. I am going to push on to just do these last few to practice, and then I can send you to do some of these at home. I know I've worked you very hard today, but I'm just conscious of us giving you as much time for revision after we're done as well. So, last page, another examples that we're going to do. So we're going to try and find, this time, the probability that X is greater than A is 0.65. Quick sketch, that's 80. Bigger than a particular value is 0.65. So this is 0.65 and this is A. So the bit we'll use over here will be 0.35. So the probability that X is less than that value is 0.35, because remember, we always need to focus on the probability that is on the left. So we have a mean of 80 and a standard deviation of 7. I can't remember what I said the probability was. 0.35, yeah? 77.30. Part B. Determine the value of B such that the probability of X being between 75 and B is 0.4. So this is going to be a similar kind of idea. Draw a diagram. We know that 80 goes in the middle, and we want it to be between 75 and B. So I don't really know where B is going to go. We want this to be 0.4. Muhi, what do you think I need to do as extra for this question? Because my calculator can't handle boundaries like this for an inverse.
You have to.
You got it? Do you know what to do? No? Anika? Good. We need to find the probability of less than 75 so that we have the entire probability below. So we're going to find the probability that x is less than 75, and then we'll add it on to 0.4. So less than 75. Good. 0.2375. So that's 0.2375 and that's 0.4. So the probability that x is less than b is 0.4 plus 0.2375, which is 0.6375. And then you can inverse that and find out what b is. $82.46. Yeah? Part C of the question. Let's block this off. We've got a different one. We've now got the probability that x is greater than c, but less than 76 is 0.2. So I'll draw my diagram. This is 80. This is 76. This is c. And we know this is 0.2. Yeah?
You do the probability of it being less than 76 minus 0.2.
Good. You're going to do, to find out what this bit here is, there's another way you could do this as well, but I'm happy with that way. If you find out the probability of x being less than 76, we can then subtract the 0.2 to get the shaded bit. Another way you could do it is to find out the probability that it is greater than 76, add it to 0.2, and then do 1 minus that, and it still gives you the same thing. But that's mathematically identical. So what are we doing? Less than 76. $0.2839. And we're going to find out this bit down here, which is the probability that x is less than c. The diagram is going to tell us it's 0.2839 minus 0.2, which is 0.0839. So c, using the inverse function, is 70.34. So C is 70.34. And then the last thing we want to do is find out the interquartile range. I might actually change that question. So I will keep it as that question, but sometimes they might say find the range between the 10th percentile and the 90th percentile, which means instead of doing 25% and 75%, you would do 10% and 90%. So if they say percentile, it just translates into a percentage instead. Okay, but I'm going to do the interquartile range really quick because I know the bell is about to go. So to find the interquartile range, we're going to do the same thing as before. We know that the lower quartile is when it's less than 25, and we know that the upper quartile is when it's less than 75. So we'll find out what L and what U are.
75.29.
For which one, the lower?
The lower, yeah.
75.29. The upper?
84.72.
84.72. So the interquartile range is U minus L, which is, thank you Hamza for doing this and saving me some time.
Oh wait, sorry, I didn't put this one. 9.43.
9.43. Does this seem reasonable from what we said earlier? We said it was, the interquartile range was mu plus or minus 2/3 of it, so seems about right, doesn't it? 80 minus 2/3 of 7. Yeah, they seem to be in the right kind of place. So we've got that there. Now, your homework is going to be to do the questions we haven't done in class so far, which is the rest of exercise 3B, and I'll decide how much of exercise 3C I want you to do. But it's quite straightforward, it's just practice. You need to get into the habit of doing this. I will be setting lots of questions on these, okay? Thank you for pushing through and getting up to that stage there. Whew, I am tired.